So we're going to start factoring polynomials. It's actually quite a big task in Algebra 2. It's not a huge task in Algebra 1, but in Algebra 2 things get crazy. So I'm going to start off with factoring polynomials number 1, and this should all be review. We're going to cover greatest common factor, how to pull it out, perfect squared trinomials, what they look like and how to quickly factor them, and then difference of squares, what they look like and how to quickly factor them. First and foremost, we have the greatest common factor. So I'm looking at these two things, or it could be 3 things, or it could be 4 things. Greatest common factor is my favorite because you always can do it first usually, and it's going to make then factoring much easier if you can pull out the greatest common factor first. So I'm looking at this and I'm thinking, okay, I like to look at my coefficients first. I see 16, I see 64, negative 64. What can I divide both of those by? The biggest number that I can possibly divide both of those by. You could think 2, sure. You could think 4, absolutely. 8, yep. Think even bigger though. I can divide both of those by 16. I can take 16 out of both of those. I'm going to look at my x's now first. Next, I see I have 3 x's in this guy and 2 x's in this guy. How many can I pull out of each? Well, 1, sure. But 2 is what I could pull out of both of these. I could pull 2 x's out of here, and I could pull 2 x's out of here. That is my greatest common factor. 16x squared is my GCF. Now I have to see, what do I have left over? If I pulled 16 out of this, those are gone. And if I pulled 2 x's out of 3 x's, I only have 1 x left. This one, if I divide negative 64 by 16, I have negative 4. And if I pulled 2 x's out, those are both gone. So when you pull the GCF out, it's just kind of like dividing. I'm just pulling the biggest pieces out. So when I pull the greatest common factor out of that lovely polynomial, it's actually a binomial because it's 2 pieces, I end up with this. And if you wanted to check your answer, you could always redistribute, and you should end up right back here. Now we're going to talk about perfect squared trinomials. I'm not sure how you all learned to factor, but anything that has 3 you could always factor the way you normally would. The thing about perfect squared trinomials that's nice is if you can start recognizing them, you can factor them kind of without thinking, honestly. So when you factor, you think, okay, what times what will get me t squared? Well, t times t will get me t squared. And then you're thinking, okay, what times itself, or what times what will get me 81? And so you could think like, oh, 2 times 81 divided by 2. Oh, that won't work. It's not divisible by 2. Then let's talk about 3. You could take 81 and divide it by 3. 81, which is 27. And that could work, but I'm trying to add to give us 18. And the thing about perfect squared trinomials that's really nice if you recognize them is they're kind of, you just are square rooting some stuff. If I square root t squared, I end up with 2 t's. If I square root 81, I end up with 9 and 9. And 9 plus 9 is 18. Perfect squared trinomials will always be written, well, can always be written like this once you factor them. T, because I square rooted t squared, plus the square root of 81 is 9, and it's quantity squared. Perfect squared trinomials are always going to end up looking something like this. And you can always square root the first and the last term. Just make sure you pay attention whether this sign right here is going to be positive or negative. I think you all have seen this before. If you haven't, then we'll practice it. And then this one is the difference of 2 squares, which is super similar to perfect square trinomials. But difference of 2 squares is easier to recognize because it has only 2 pieces. The thing I like about difference of 2 squares is I can easily figure out what my factors are. So first and foremost, again, these bad boys, you can just square root them. So the square root of 16 is 4. The square root of k squared is just k. So each of my factors are going to start with 4k, because 4k times 4k is 16k squared. And then the next one, square root 1, well, that's 1 and 1. The thing about difference of 2 squares, the reason there's no middle term is because one of these is going to be positive and one of these is going to be negative. That's why your middle term cancels each other out, because you end up with positive 4k and negative 4k, and then those give you 0. So difference of 2 squares I think is easier to factor because that's just your answer. You're just square rooting the first term, square rooting the last term, and then make sure one has positive and one has negative.